Good afternoon. Today I will talk about multi-level security. For every organization, if they want to develop a product or system which is secure, the first things you need to do to make the security policy. After that, based on this security policy, you will develop some security model. Based on the security model, you will write some code, then realize this kind of security policy. Make a secure product or system. So what's security policy? Security policy outlines the security requirements for an organization. It is an abstract term that represents the objectives and goals a system must meet and accomplish to be deemed secure and acceptable. Security policy is composed of a lot of rules and practices that dictates how sensitive information and resources are managed, protected, and distributed. It also expresses what the security level should be. Is a top security level, is a security level, or unclassified. Sometimes the security policy also provides the framework of the system's security architecture. Based on the security policy, you need to develop a security model to meet the security policy. A security model is a symbolic representation of a policy. Generally, a security model outlines the requirements needed to support the security policy and how authorization is enforced. It will also map the abstract goals of a policy to information system terms by specifying explicitly data structures and techniques that are necessary to enforce the security policy. It also maps the desires of the policymakers into a set of rules that the computer system must follow. In fact, security model is usually represented in mathematics and analytical ideas. These ideas are then mapped to system specifications and then developed by programmers through programming codes. In the past, there have many security models. One is called the Bell-LaPadula model. The second is Biba model. The third is Clark-Wilson model. Then also we have Chinese wall model, information flow model, non-interference model, lattice model. This kind of models, some model is to realize the confidentiality. Some models are used to realize the integrity. Some model is used to realize the availability. So depending on your aim, you will adopt different model there. For textbook reading, you guys just go to chapter 8. Okay? Let's first introduce some basic idea on multi-level security. If you guys want to go to work in military and government systems. Generally, you need to get security clearance. The security clearance has different levels. For example, you have top security level, and confidential level, and unclassified level. Generally, for a person with top security clearance level, he can access top secret information, security information, confidential information, unclassified the information. But for the person with security clearance level, he can only access security level, confidential level, unclassified level information. For the user with confidential level, he can access confidential information and unclassified information. But if the person just has the unclassified security clearance level, he can only access unclassified information. Okay? Why they set this kind of multi-level security? We have 4 levels here. Okay? The reason is prevent users from obtaining access to information for which they lack authorization. In fact, Bell-LaPadula model is a multi-level security model. In this model, the information and the users are also classified in different levels. For example, the user can be classified as top security level, confidential level, and unclassified level. For the information, also we can classify top security, confidential, and unclassified level. But in this model, we use the subjects. We don't use users and the person, because a subject could be a person, also could be a piece of program. So we just use the term subject here. We define a subject is an entity capable of access objects. For the information, we don't use information here. We use the specific objects because the information are saved in the objects. Okay, so we classify the objects the subject can access as top security objects, confidential objects, and unclassified objects. Also, we have 4 levels here. The definition of an object is that it is a resource to which access is controlled. Okay? For example, in your system, the files are the objects. Okay? There are 100 files, then you have 100 objects. In Bell-LaPadula model, there are 2 policies. One is called simple security policy, means low read up. A subject at a given security level may not read an object at a high security level. For example, a security researcher can view public or security file. However, he cannot view top security file because top security is higher than security. Let's think about this one. This is the subject with different level. Top security, TS, okay, security, confidential, and also unclassified. classified. For the object, we also have top, okay, security level, confidential level, and unclassified level. So for the security level, they cannot view top security level. It only can view the same level or the low level. For the confidential level, cannot view security level and top security level. It can only view confidential level and unclassified level. For the unclassified level, it cannot view confidential level, security level, and top security level, but he can only view unclassified level. That means only can view the low level, okay? Cannot view the up level. That's called simple security policy. Another security policy is called star policy, means low, right, down. What does this mean? This means a subject at a given security level must not write to any object at no security level. For example, we use this same level. You have subject, okay? Then you have objects. So you have subject, some TS level, top security level, confidential level, and unclassified level. For the object, also you have top security level, confidential level, and unclassified level. So low, right, down, that means the subject is a top security level. They cannot write to security level. That cannot. Also, it cannot write to confidential level and cannot write to unclassified objects. Let's change the pen. Change the color of the pen, okay? Then for the security level subject, it cannot write to confidential level and unclassified level. It can write S level or up level. This is called low, right, down. Besides these two policies, we have a strong star property, which means subjects may write to objects with only to a match security level. That means S level subject can write to S level object. C level subject can only write to C level objects, and the others are the same. Let's explain the BLP policy in details. Assume that we have a lot of objects, and these objects are classified into different levels. There are lowest level objects. Also, we have highest level objects. And the subject is in the current level. So based on the low reading up and no write down, which means this subject can write this kind of objects, but it cannot write to these objects. The same, this object can read these objects, but cannot read these objects because it's a high layer. For the same layer, it can read and write. Let's see whether you guys can answer the two questions. So we have different subjects with different level. Okay, this subject is top security level. This guy is security level, and this guy is confidential level, and the last guy is unclassified level. Also, we have some objects here. Okay, these objects are top security level. These objects are security level. These objects are confidential level. These objects are unclassified level. So let's answer the first question. The first question is, can this guy write to this object? Because this guy has top security level, so it's higher than the level of this object. Then it can not write to the low level. So this is no. Let's see the second question. Can S subject write to U objects? Okay, that means this guy. Oh, no. That means this guy. Okay, can this guy write to U object? Because S level is higher than U level. So the answer is still no. Okay? We just explained the basic idea of BLP model. In fact, the BLP model is a very simple model. However, it is useful. In fact, many systems can be implemented using the BLP model. For example, for the file system access control was the obvious choice. In fact, in history, there is a computer system called Multics system. They implemented BLP model. Unix inherited its discretional AC from Multics. Thus, Unix system also implemented BLP. This shows another practice problems. In this problem, we suppose that you have a security system with two subjects and two objects, and H is a high security level and L is low security level. See here, we have object 1. It has high security level, and object 2 has low security level. Also, we have two subjects here. Subject 1 has low security level, and subject 2 has a high security level. So I wish you to implement that. We have another practice problem here. In this problem, we suppose that you have a security system with two subjects and two objects, and H is high security level L means low security level. This table shows these two objects and two subjects. Object 1 has high security level. Object 2 has no security level. Subject 1 has low security level and subject 2 has high security level. If let you implement the Bell-LaPadula model of security for this system, please fill the access rights permitted by the model for each subject-object pair in the following matrix. Let's determine where the subject 1 can read and write object 1 or object 2. First, let's compare the level of subject 1 with the level of object 1. Subject 1 its level is L. Object 1 its level is high. So let's determine which subject 1 can write to object 1. Because object 1 is high level and subject 1 is low level based on no write down. That means subject 1 can write to object 1. Based on no reading up, subject 1 cannot read object 1. Let's consider object 2. Object 2 has high security level. So we compare with the security level of subject 1. Object 2's level is high. Based on low reading up. Oh, I'm sorry here. In fact, the object 2 is L, is not H, okay? We just remove it. Okay. So because subject 1 and object 1 has the same security level, so subject 1 can read and write to object 2. Let's consider subject 2. Subject 2 has high security level. So let's compare with object 1's security level. Because both of them have high security level, they are in the same level. That means subject 2 can read and write to object 1. Let's consider subject 2's level and object 2's level because H is higher than L based on the no write down, no reading up. That means subject 2 can read object 2, but it cannot write to object 2 because object 2 is in lower level.